Waiting for mortgage rates to drop could be a costly mistake. Once rates drop, new home buyers will enter the market and prices will soar even higher. At Churchill Mortgage, you can get a free analysis and learn how to avoid the trap of waiting for interest rates to drop. Buy now and refi later at churchillmortgage.com. This is a paid advertisement. NMLS ID 1591. NMLS ConsumerAccess.org. Equal Housing Lender. 1749 Mallory Lane, Suite 100, Brentwood, Tennessee 37027.
When you visit Arizona, time is measured in moments, not minutes. Like the moment your work stress disappears as you kayak through the canyons. Or the moment you discover the life-changing effects of prickly pear chocolate. But nothing beats the moment you see the Grand Canyon for the very first time. Visit a new state of mind. Learn more at hereyouareaz.com.
Hi there, thanks for joining us. This is Space Nuts. My name is Andrew Dunkley, your host. I hope you're well. Thanks for joining us. Coming up in this episode, some fascinating stories. We've been pumping groundwater out of or from beneath Earth's surface for, decades and decades, probably longer. And now it starts to look like we have caused a little bit of a change. We'll look into that. And there is a relationship, it appears, between cosmic radiation and earthquakes. We'll also be answering audience questions about Martian water, a what-if question from Ash, and where would Fred and I go if we could go anywhere, anytime, to visit our favourite places in the solar system. Well, that's what Neil and Aurora want to know, so we'll try and answer that. And much, much more coming up on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining us to talk about all that and whatever else pops up is Professor Fred Watson, astronomer at large. Hi, Fred.
Andrew, good to see you again.
You too. Hope you're well.
Yeah, good enough, thank you. All good.
Now, you're doing it computer-free again this week?
We are, yes. You're sitting on my mobile phone, looking quite small, but that's all right. I look even smaller, so that's probably the way it should be.
Yeah, it must be nice to be without a computer. We get strapped to those things.
Well, I'm afraid I'm still strapped to it, but the only issue is that I can't use it for Space Nuts because of as you said, it's the antique operating system. I think my operating system is called Diplodocus or something like that.
Diplodocus 3.1. Yeah. Well, mine's relatively new. I haven't had it for a year, but even from day one, it showed signs of being pretty well useless. Yeah. Last week it did 3 updates in a week, and I thought, what on earth's going on? Yeah. It's ridiculous. Yeah. Now, we've got a lot to talk about.
Yep.
So let's get stuck into it. This story about groundwater. Now, you and I know groundwater very well because where I live and where you used to live, we're sort of above the Great Artesian Basin, which takes up a vast area of eastern continental Australia, from Queensland right down into Victoria and South Australia. It's a massive underwater river system, if you like. And even around here, we have hot springs popping up here and there and everywhere. And some of them have been commercialised. And, farmers have been taking water out of the ground for yonks, for irrigation, etc. But it now appears that doing that has had an effect.
Indeed, that's right. And you're stirring my memories there, Andrew, because, of course, when I lived in Coonabarabran, we weren't far away from, was it Burren Junction, where there were hot springs that you could go and swim in? I remember doing that back in the 1980s. Yeah,
Burren Junction, Moree, Lightning Ridge, all those places, hot springs everywhere. And some of them naturally pop out and bubble out of the water, but a lot of, there are hundreds and hundreds of bores, including Dubbo. We source a lot of our domestic water here from the Great Artesian Basin.
Yeah. When I lived in Coonabarabran, I had a 90-foot bore, which went down to the reservoir of water underneath the Warrumbungle Mountains, believe it or not,
Wow.
which contained more water than Sydney Harbour. So
Incredible.
Anyway, coming back to this, it's a really interesting story. And what we're talking about is shifts in the position of the Earth's rotational poles by essentially a few meters at most. And that happens naturally. So if you imagine yourself standing on the North Pole or equally the South Pole on the ice, of course, there's no marker there saying this is the exact pole. There's probably a flag or something that in itself would move because the ice moves. But basically, if you think of that scenario, just due to things like the ocean tide movements, the Earth's core having sloshy material in it because it's liquid, at least part of it is, all of that contributes to just a change in the exact direction of the spin axis of the Earth, and it's the spin axis that defines the poles. So if you could stand on the North Pole and actually see, or stand at the northern tip of the Earth and see the North Pole itself, it would wander around over actually periods of about a year or so. Now, researchers look at that. They basically can explore that, not by standing looking at some imaginary point, but by actually astronomy helps with this. And now we've got GPS and all of those things which help us to work out where the Earth's pole is. And what's happened is that the very clever people who do this stuff, they look at the observations. Yes, this is how the pole is wandering around. They also theorize where it should be, because what they can do is they can work out things like ocean tides and that sort of thing and calculate what the movement of the pole should be. And they did this for data over a period between 1993 and 2010. So a fairly significant chunk of data, 17 years worth, which has been published recently in the Geophysical Research Letters. It's the Global Geophysical Union's publication. And they tried to fit the known movement of oceans and things like that, due partly to climate change. Ice is melting and things of that sort. Yeah. They tried to fit that to the observed motion of the pole. And it turned out that they were something like 80 centimeters out in their calculation. Now, that doesn't sound much when you're talking about a planet, to not know where its pole is, to an accuracy of 80 centimeters. But this was a concern. Actually, it was 78.5 centimeters to be accurate.
Okay.
And what they had to do in order to correct for that is allow for what we've just been talking about, the use of groundwater. Groundwater comes out the ground, it's used for agriculture or swimming in or whatever you use it for, but eventually it finds its way into the ocean because it joins rivers when it's drained away. And in particular, they were looking at groundwater usage. It was in northern India, if I remember rightly, and I think Western United States or Western North America. I haven't got those figures in front of me, but those are the regions where the most amount of groundwater was being used. And you can imagine that because these are fairly dry areas of the planet. North America, northwestern India, at mid latitudes. And so once they'd put that into the model, it fitted perfectly with the information. Bless you, Andrew.
Oh, you saw that, did you?
I guess what was happening. Yeah, didn't hear it, so that's good. So it is clearly from this we can deduce that the motion of groundwater, the use of groundwater, is actually impacting the Earth on a global scale. It has an effect on the tilt of the Earth on the position of its axis. Very tiny effect, but one that we understand and can now. We can now allow for in the calculations. It's really quite remarkable stuff.
Is it likely to continue to have an effect because we're still pumping the stuff out?
Yeah, yes, that's right. So, when the next tranche of data are examined for this kind of thing, that will probably show similar effects. I don't know how often these studies are made. Probably, certainly in the world of science, there are people looking at these things all the time.
Yeah.
So we might hear more about this, before too long, that we can talk about once again on Space Notes.
What if we got all the water out and it ended up in the ocean? What do you think the effect might be then?
So, yeah, you can well imagine, given the resources, how much of the Earth's water is groundwater, and I don't know the figure for that, but it would be a significant amount compared perhaps with the amount in the oceans. If you dumped it all in the oceans, it would be bound to have a more significant effect than ever. It's been long, you and I both know, having lived in a place that relies on groundwater, that it is usually regarded as an infinite resource. If you don't have water, put a bore down it. She'll be right.
Yeah.
But the danger is that you will actually drain these aquifers completely and run out of water.
Yeah, we thought for a long time that it was just a limitless supply.
Yeah.
We're now learning that's not the case. And for many years, and I reported on this when I worked for the ABC, particularly during the 90s and the early 2000s, that there were so many bores that had been created that they never turned off. They just consistently ran.
Poured water.
And now they've realised they can't let that happen. So they've been going around capping them to try and stop the water flow. And it became a really big problem out here. But on the plus side, I live in a city of 50-odd thousand people, 50,000, and we're drought-proof because of groundwater.
Yeah, that's amazing.
We never can run out of water. Even in the height of the last big drought, we never had a problem with water supply because of groundwater. So it's really critical for life in these sort of semi-arid zones of the world. Yeah. And we don't get a lot of rainfall here compared to some places. We get a reasonable amount, but we certainly do rely on groundwater to keep our supplies up. So, but it's interesting that taking it out, and you're right, it ends up, because after we've used it, it ends up in the rivers, or it gets evaporated off and it rains somewhere else and goes down into the rivers and ends up in the ocean. I mean, water exchanges around the planet all the time. It's always rotating through the various systems that exist. But it does sound like we're creating a bit of a lopside in this situation.
Pushing the planet over.
Yeah. Here's a question just in regard to the axis. If you could stand on the tip or the bottom, doesn't matter which one, of the if you're right on the point of the axis of the Earth, would you notice? Would it be any different to standing out in the street here?
No.
Huh.
There are slight phenomena that are so slight as to be not measurable. I mean, where you are and where I am actually, where at latitude, your latitude is about 32, I think. South, we're about 34 south here in Sydney, which is not that far from the equator. And so there's a kind of centrifugal effect that makes us slightly lighter because the Earth's spinning. But it is such a tiny effect that it's not anything that you would notice. You wouldn't feel that any heavier when you were at the North Pole or the South Pole than you do on the equator.
Yeah, unlike other planets.
Yeah, that's right. Some planets you certainly would.
Yeah. All right. Now, where can people chase that story up if they're interested?
It's actually, it was in Terra Daily. Terra being the Earth, of course. T-E-R-R-A, not rather than T-E-R-R-O-R.
Okay.
Terra Daily, news about planet Earth.
Yeah, really interesting one. Okay. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
Well, shopping for a car?
Yep, Carvana made financing a car as smooth as can be.
Oh, yeah?
I got pre-qualified instantly and had real terms personalized just for me.
Doesn't get much smoother than that.
Well, I got to browse thousands of car options on Carvana, all within my budget.
Doesn't get much smoother than that.
It does. I actually wanted a car that seemed out of my range, but I was able to add a cosigner and found my dream car.
It doesn't get much...
Oh, it gets smoother. It's getting delivered tomorrow.
Visit Carvana.com or download the app to get pre-qualified today.
Let's just take a short break from the program to tell you about our sponsor, NordVPN. Now, I've told you about a virtual private network before, and as a Space Nuts listener, you get extra benefits just by logging on to a specific URL. That's nordvpn.com/spacenuts, which I'll repeat a little later. But when you log on to that URL, there's an exclusive deal which NordVPN offers so that you can protect yourself from scams and hackers, and just basically an added layer of security for your home network, or if you're out in the street using your smart device on a Wi-Fi system, anything like that. And one of the things I really like about NordVPN is they back their products, a 30-day money-back guarantee. So when you get in there, you'll see that it's a system that's backed by some of the big names in business around the world, including the BBC. Click on the Get NordVPN link, and you can see all the products and services that are on offer, and you can buy them in different levels of package. I just went the whole hog for a 2-year plan, which gave me an extra month, and it really brings the price down. And so I've got the whole bundle, but you don't have to do that. You can get the basics, what you need, the VPN, the malware protection, the tracker and ad blocker, or you can add to it the password manager. Now, that's a thing I find extremely handy. All my usernames and passwords are locked away in there very securely, and when you want to log into something and you can't remember the password, it can do it for you. It's really fantastic. There's also a data breach scanner, and you can add on a terabyte of cloud storage, which is also very handy these days with the amount of material we store online. So check it out today, all those wonderful products by our sponsor NordVPN, nordvpn.com/spacenuts, and then click Get NordVPN, which will take you to all those options. I have been using it for a while now. I swear by it. I think it's a fantastic product. And as I said, I use everything. So you will find it most beneficial for whatever your circumstances are. That's nordvpn.com/spacenuts for an exclusive 30-day money-back guarantee deal with our sponsor, NordVPN. Now back to the show.
3, 2, 1.
Space Nuts.
Now to our next topic, Fred, and this one is focused on Earth as well, but this one's a real surprise that cosmic radiation may, in fact, be having some sort of effect on our earthquakes. This sounds like something out of science fiction.
It does, doesn't it? Actually, we might have to rename the show Earth Nuts after today, because 2 Earth stories. Yeah. But it is the Earth's a planet, and we learn things about the universe by examining the Earth. And this, as you say, has been a complete surprise, at least to me. And so what we have is let's step back. We all know what earthquakes are, so probably don't have to explain those. Yeah. But cosmic rays are subatomic particles that come down to us from who knows where. It's actually, the source of them is not that well understood. These are high energy subatomic particles that come from outside the solar system. So they are from deep space, maybe even from distant galaxies. And that flux of particles has been known actually for more than 100 years, that particularly high up in the atmosphere, you can detect them. When they interact with the atmosphere itself, they produce what are called secondary particles, because they hit the atoms of the atmosphere, clout them, and that then causes a cascade of other less energetic particles. And it's those that we can detect with various cosmic ray detectors. It's not something that is, I was going to say it's not rocket science, but well, it probably is. But you know what I mean. It's a standard procedure. It's standard practice in cosmic ray astrophysics, and there is a whole discipline of particle astrophysics. So to cut to the chase, there is a project called CREDO, CREDO, which I like as an acronym. It stands for Cosmic Ray Extremely Distributed Observatory. And it's actually a virtual observatory that essentially takes cosmic ray observations from many different observatories. Usually these are at high altitude, they're on mountaintops, but many different observatories around the world. And it's actually initiated by the Institute of Nuclear Physics of the Polish Academy of Sciences back in 2016. And it's essentially, as I said, it's a virtual observatory, so they collect data kind of from the whole planet. Now, what they've done is they've done statistical analyses, as you'd expect with everything. You know, if you notice changes in the rate of cosmic rays, can you link that to something else? In this case, they've linked it to earthquakes. And not just that, they've actually found a significant correlation. So they have apparently looked at data collected since 2005 from various, as I said, from various cosmic ray databases collected at different observatories. And what they find, and I'm going to quote this because it really succinctly describes what this phenomenon is. It comes from the press release from the Polish Academy of Sciences. It says, in each case, in each analysis, for the period studied, a clear correlation emerged between changes in the intensity of secondary cosmic radiation, that's these air showers that come from the radiation meeting the atmosphere, secondary cosmic radiation, and the summed magnitudes of all earthquakes with magnitudes greater than or equal to 4. Ooh. So if you add up all the earthquakes with more than 4 or equal to 4 on the Richter scale, and compare that with the flux of cosmic rays, you get this correlation that earthquakes are more when cosmic ray input or flux is higher. And here's the really neat bit, Andrew, and I'm quoting again from the press release. Importantly, this correlation only becomes apparent when the cosmic ray data are shifted 15 days forward relative to the seismic data. This is good news, as it suggests the possibility of detecting upcoming earthquakes well in advance.
Wow.
Yeah, work that one out.
This sounds like an April Fool's Day joke.
Let me just check.
No, it's not.
No, June the 15th, 2023.
Okay.
So, I mean, they suggest a mechanism for this. And unfortunately, it's not, yes, if you see an increase in cosmic ray flux, you can say that 15 days later, there's going to be an increase in the world's earthquakes when you add them all up. But you can't pinpoint them to any one place.
Yeah, well, that would be the trick, wouldn't it?
It would. And that, at the moment, these data just simply don't let you do that. So clearly, being good scientists, these scientists have actually tried to understand why this might be. And there is a clue in that cosmic rays, of course, are affected by the Earth's magnetic field. And the Earth's magnetic field comes from basically eddy currents in the liquid core of the planet. And so if you've got sort of disturbed motions within the core of the planet, they might cause earthquakes, but also affect the magnetic field in such a way that you get this effect on the cosmic radiation. Let me quote again. It's beautifully written press release from the Polish Academy of Sciences, as reported here by phys.org, one of our favourite websites. The main idea here is the observation that eddy currents in the liquid core of our planet are responsible for generating Earth's magnetic field. Yep, that's right. This field deflects the paths of charged particles of primary cosmic radiation. Thus, if large earthquakes were associated with disturbances in the flows of matter that drive the Earth's dynamo, these disturbances would alter the magnetic field which in turn would affect the tracks of the particles of primary cosmic radiation in a manner that depends on the dynamics of the disturbances inside the planet. As a result, ground-based detectors should see some changes in the numbers of secondary cosmic ray particles detected, and that's what they found.
Okay.
It's such an unexpected and interesting result, but once again, uncovering some of the secrets of our own planet.
Yeah, fascinating. So let me try and nutshell this, because I'm still kind of trying to get my head around it. So they're not saying this is causing earthquakes. There's so many different things that can cause earthquakes, and that, tectonic plate movement, volcanic eruption, blah blah blah. But what they're saying is that there are changes in the magnetic field because of the eddies in the core, and that lets more cosmic radiation get in and enhances the effect of an earthquake. Is that what I'm hearing?
No. The two are no. You're right. It's not the changes in the magnetic field. While they might cause the earthquakes, the cosmic rays themselves don't have any enhancement. It's the magnetic field that diverts the cosmic rays, so we don't see them, or we do see them, or whatever, or focuses them, basically. But that's not causing the earthquakes.
No.
That's just a secondary product of the changes in the Earth's magnetic field.
Okay.
So so the root cause of both of these is the changes in the Earth's magnetic field. So it causes earthquakes, and it also causes a change in the cosmic ray flux. But the cosmic ray flux doesn't cause the earthquakes.
Okay.
That's the link.
All right.
There is another. If we've got time, Andrew, there's a kind of postscript to this piece, which is really intriguing and feeds directly into some of the main stock in trade of space nuts. They've also detected a periodicity in this. In other words, there's a regular change in the influx of cosmic rays, and hence the amount of earthquakes, that's got a similar period to the solar cycle, about 11 years. So the solar cycle is something we've known about for more than a couple of hundred years, where you count the number of sunspots on the sun's surface, and if that's a measure of solar activity, that number changes over this 11-year period.
Yeah.
You get maximums and minimums, which we've talked about before. But they find this. Let me just again read from this marvelous article. A major surprise is the large-scale periodicity of the correlation, a phenomenon no one had expected. Analyses show that the correlation maximum occurs every 10 to 11 years, a period similar to the solar activity cycle. However, it doesn't coincide at all with the maximum activity of our star. And so they're suggesting there might be other factors in this periodicity, and one of the possibilities is whether it might be something to do with dark matter.
Oh, here we go.
Here we go. As the Earth perhaps orbits through the dark matter in the stream of as a stream of dark matter particles around our solar system, and perhaps that stream itself is somehow affected by the sun, giving this link between the periodicity of the cosmic rays and of the solar cycle. Maybe there's some issue there that is to do with some of these real mysteries, what are called non-classical explanations of phenomena. Because definitely dark matter is non-classical, since we don't know what it is.
Yeah.
So what an interesting piece of research, which might have far-reaching consequences.
It might. Wouldn't it be great if you could predict earthquakes? I saw a report some months ago now, and I can't remember the details, but they found another indicator that could predict earthquakes. There was it might have been to do with the magnetic field, actually, now that I mention
Possibly,
it.
yeah.
But some other research showed sort of fluctuations in the magnetic field that suggested it was an indicator of a potential earthquake situation. This might be related to it by the sounds of things.
Here's a wild speculative suggestion from me. We think animals can sense earthquakes. Are they picking up tiny vibrations from the ground? Or, given that we know some animals have quantum magnetic field detectors built in, and these are birds, is that what we're seeing here?
Yeah.
Andrew, you may have lost my picture.
Have you not plugged the cord in to charge your phone?
I forgot to plug the cord in. Hang on a minute.
Dear, oh dear.
Oh dear. Well, this is new territory.
Yes.
Using the phone for this. See if I can plug the cord in. I know we're in uncharted waters.
At least it warns you instead of just cutting you off.
It says I've got 20% in the battery. The fact that there's a warning there, that's all right. Let me get rid of that. You might be able to see me.
There he is again.
Yeah.
Okay. Yes. Yeah, I suppose, Fred, we really should keep our minds open about the cause and effect of these kinds of things. There's so much we don't know about the universe as a whole and the effects on various planets of cosmic radiation and particles and dark matter and all of these things. We really need to probably keep a very open mind about how these things relate to each other.
Yeah, I think that's absolutely right. And clearly these researchers have demonstrated open-mindedness. The snag with a mind that's too open is your brains fall out if your mind's completely open.
Or you become an astrologer.
Well, look, I had and I'm sorry, I've probably told you this tale before, but many years ago I was doing it might have been the International Year of Astronomy. I can't remember. It was quite a long time ago. I was doing a public lecture in Berlin, which was, it's a place called Urania, which is a science centre where they all speak English, which is handy. But I was doing this talk, and a gentleman in a pink suit came into the talk, and he had a kind of staff with him, which he walked in a very prophetic manner. He had a few followers with him. And at the end of my talk, which was about Pluto, he said, actually, I come from Pluto. My name is Messenger 9, and I'm here to tell you that because of Pluto, there are going to be dangerous earthquakes within the next 6 months. And he went on about these earthquakes, which he's predicting. And it was quite funny because the rest of the audience were all, there was ribald laughter for quite a lot of it. But he shot himself in the foot because somebody said, where are these earthquakes going to be? And he said, it will be 30 degrees west of the equator, which doesn't make any sense at all. So that was kind of the end of the show. And I talked to him afterwards. He said, actually, I'm not from Pluto. I'm from, where was he? He was from
Edinburgh.
South America. Somewhere in South America. He was a really interesting guy, but he's obviously...
Yeah, had too many Fruit Loops for breakfast. Yes. Never mind.
Pink suit they got.
Yeah, that would do it.
Sadly, because this was Germany, they'd recorded the whole talk on a CD, and this conversation was there at the end, so I could report it verbatim in one of my books.
Wow.
But nobody took a photograph, which I'm really sorry about, because he was so imposing, this guy. He was striking, man.
Fascinating. All right. If you want to read up that story about cosmic particles and their relationship to earthquakes, phys.org, I think it is, phys.org is where you will find it. This is Space Nuts, Andrew Dunkley and Professor Fred.
When you download the Baker's app, you have easy access to savings every day. Get the most out of weekly sales and receive personalized coupons to save on your favorite items, all while earning 1 fuel point for every $1 spent. Baker's makes it easy to save while you shop, whether it's in-store or online, so you get the most value out of every trip, every time. Download the Baker's app now to save big on your next purchase. Baker's, fresh for everyone. Must have a digital account to redeem offers. Restrictions may apply. See site for details.
Now, during the Jeep Black Friday sales event, get $12,500 in lease support on the 2023 Jeep Grand Cherokee Overland 4xE. $12,500 lease support includes cash allowances and $7,500 federal EV incentive provided by lender as a capitalized cost reduction and is subject to change without notice. Lessees cannot claim federal tax credit on their personal tax return. Please confirm this information to ensure its accuracy and availability. Consult a tax professional for details and eligibility. Not all lessees will qualify. Residency restrictions apply. Take delivery from dealer stock by 11/30. Jeep is a registered trademark.
Space Nuts.
Okay, Fred, it is time to hand it over to the audience and deal with some questions. We got a whole bunch in, over 30 questions, so we've got a bit to work with, and we're going to do them all right now.
Okay.
Or maybe 1/10 of them. Let's start off with a question from Nigel.
Hi, Space Nuts around the world. Hi, Fred. Hi, Andrew. This is Nigel from Brisbane, Australia. I'm amazed at the podcast, how it reaches all around the world. And people from far distant places, such as Norway to South America to Africa, call in with questions. Simply amazing. Anyway, my question is, Mars had oceans of water that evaporated into space. Could any of that water reach to Earth? Extra questions are, could water clouds form in space? And if they crashed into a planet like Earth, would they rain down? Okay, love the show. See you later.
A lot in that. Thanks, Nigel. Lovely to hear from you. We know about the water on Mars. We think a lot of it's actually still there, don't we, under the ground?
We do, that's right. Great questions from Nigel there, and some of the points he makes are absolutely on the money. With Mars's water, yes, as you say, we think climate change happened on Mars probably very early in Mars's history. We think for the first maybe billion years of its history, it was warm and wet, and then because the planet's not big enough to sustain the kind of tectonic activity that we've just been talking about, it cooled. This magnetic field, which was never strong, is more or less non-existent now. And the effect of that partly was to freeze the water. So there is groundwater on Mars, but it's in the form of ice. It's permafrost. But the water that was lost to space was lost probably as the two components of water, because with the lack of a magnetic field, you've got and the lack of a thick atmosphere, you've got pretty high energy radiation from the sun, both particles and ultraviolet. And the effect of that on a water molecule is to split it into hydrogen and oxygen. And the hydrogen being the lighter stuff, that just wanders off into space. So we think a lot of the water was dissociated in that way, and the hydrogen headed off. And actually, there's a spacecraft called Marvin, which it actually analyzes the gas emission from Mars, and it can still detect that stuff happening. There's still, stuff leaking into space. It's a long time since I've looked at the stuff coming from Marvin, but several different elements you can find leaching off the planet into space. So it's still happening.
Fascinating. Okay.
The idea of clouds of water in space, it sort of happens. I mean, water is the most common two-element molecule in the universe, so it is everywhere. Usually, it would be in the form of vapor, and we see that in these giant molecular clouds. Telescopes like ALMA, the Atacama Large Millimeter Array, sensitive to water, the frequencies that water emits. But also in the cold of space, it freezes. And so you get things that we call comets, which are just exactly what Nigel suggested. They're lumps of water ice floating around in the universe. And we think the comets in the Oort cloud, that spherical shell of comets around the extremities of the solar system, we think that's the last vestiges of the cloud of gas and dust that formed the solar system. So Yeah, and they've obviously rained down on Earth. We think that at least some of the Earth's water came from these lumps of ice called comets.
Yeah, but recent studies, I suppose, have suggested that there wasn't there's too much water on Earth for just comets to be responsible. So they think when the planet formed, it gathered water in that process, which has leached out to create our oceans. So
yeah, it's. I think there's still, though, it's certainly some of the water came from comets.
Yeah.
This is all about what we've discussed before, the isotope matching, the ratio of heavy water to normal water in comets. Some comets have a ratio of heavy to normal water that matches that in the Earth's oceans, but a lot don't, and that's why there's some doubt about whether most of the oceans of the Earth came from comets, or whether, as you said, there's some of it is what you might call primordial water, water that was there right at the beginning.
It's a good thing it doesn't go off. Now, just to paraphrase another part of Nigel's question, is it possible for us to get more water through cosmic rain?
I suppose, it not the water's not going to just come down like snow.
No,
it would be in lumps of ice. There may be small cometary debris chunks that we see breaking up in the atmosphere. Most of the stuff that hits the Earth's atmosphere is meteoritic. It's basically bits of asteroids, tiny dust particles. I guess some of that might be water, but I think it's more likely. In fact, I can rule that out. I'm thinking aloud here. Because we're within the sun's frost zone. We're in the Goldilocks zone.
That's right.
So any water in this area will be vaporized.
Yeah. Okay. So that writes that off. I think we covered everything for Nigel there.
Yeah.
So thanks, Nigel. Great to hear from you. And speaking of collisions, here's a what-if question from Ash.
G'day, Fred and Andrew. Ash from Brisbane here. Got a bit of a what-if question since I know you guys like them so much. Budding science fiction writer, and I was just toying around with the idea of a eccentric billionaire planning on locating a whole bunch of humans to Mars, but knowing that it's too small to hold an atmosphere, wanted to land a bunch of retro rockets onto the dwarf planet Ceres to slow it down in its orbit and gently crash it into Mars to give it the extra mass it needs to hold on and also reignite some of the heat within. Tell me, is this even possible? Can you slow a dwarf planet down if you had enough rockets pointing in the opposite direction of its travel? And what would the consequences be for the rest of the solar system having such a large collision at this point in time? Would there be space junk flying around there that would come to impact Earth? Yeah, just thought I'd get that one out there and let you guys tell us all what you think.
Yeah, we'd love to toy with that one. Thanks, Ash. I think we did learn that we can maneuver objects through the DART mission test last year, and that was a minuscule movement by crashing a spacecraft into the moon of an asteroid. To move a whole dwarf planet, that would be a big ask. And I imagine that if you're trying to move the thing, you'd also have to take into account that gravity would be a factor in getting around through the solar system on your journey back to Mars, which is not a short trip.
It's not. Yeah, I do see a few problems with this.
Really?
I mean, Ceres is nearly 1,000 kilometers in diameter. Mm-hmm. It is, exactly as Andrew said, it's a dwarf planet. And I don't know what its mass is, but I think you'd struggle to move it pretty well in any amount with any kind of rocket motor that we can think of. And it would be tricky because Ceres is rotating. So how are you gonna move it with rockets? Because the rocket, so if you plump one on the surface and set it off, so it's like a firework going vertically upwards, that's trailing out its it's actually changing direction all the time because the dwarf planet's rotating. I can't remember what series rotation period is, but the mechanisms that you, even if you could get all those rockets together, every rocket ever made in the universe, that might just about do it, but certainly not anything that we could cobble together on our own planet. So I think moving series is a non-starter. If you could, and you did have a collision like that, it would take, maybe 100 million years for the debris to settle well enough that you could actually make the planet big enough to colonize, by which time that eccentric billionaire might not be around anymore.
Oh, no, if he's an eccentric billionaire, he will have found a way to stay around that long.
That's right.
Yeah. Series rotation is 9 hours.
There you go.
And its mass is 9.1 times 10 to the 20th kilograms.
Yeah. So.
Yeah, which is about 2.2 grams per cubic centimetre.
Yes, it's quite low density in that regard, but still not low enough to make it possible to shove it around with rockets.
Yeah, I like the science fiction thought behind it, because you can do anything with science fiction. Because they did make a Korean movie not so long ago about the Earth sort of reaching a point where it couldn't stay where it is because of the sun. So they strapped a bunch of rockets to it and moved us out to Saturn or Jupiter or something. They did.
Oh, well, if they did it, then if they did it with the Earth, you can do it with the series.
All these mega rockets that were dragging us through space. It was bizarre. It was a bizarre film. It was one of those films, Fred, that was so horrible I couldn't stop watching.
Oh, really?
I just had to know what happened in the end.
Where is this going next?
Yes.
This is the trouble why I could never be a science fiction writer, because I'm totally constrained by the laws of physics, and that is not what you want.
And yet, you gave me the idea for the twist at the end of the Turanian enigma.
Okay, there you go.
Yes.
There you go.
I'll give people a hint. We've already talked about it today.
Yeah. Okay.
Yeah. Thank you, Ash. A no-go, I'm afraid. Finally, we will hear from... we've got a duo. I'll let them introduce themselves.
Good day, Professor Watson and Mr. Dunkley. This is Neil.
And Aurora.
Calling from Calgary,
Alberta, Canada.
And we have a question about your favorite places in the solar system and the universe. If you could take a trip anywhere in the solar system at any point in time, where would you go and when? And also, if you could take a trip anywhere in the universe at any time, where would you go and when? And of course, to both questions, why? Thank you so much. We absolutely love the show. Long-time listeners, first-time callers.
Thank you.
Bye-bye.
Thank you, Neil. Thank you, Aurora. So lovely to hear from you. And I was only in Calgary a month ago, and I didn't see you. So that's...
How do you know you didn't see them?
Well, that's a good point. Yeah. But I loved Calgary. We didn't get to spend a lot of time there, but saw the Olympic facilities from the Winter Olympics that were hosted in Calgary, and they've got this beautiful ice rink in the centre of the city there, which had no ice on it while we were there, but you could see how it all worked. They even still have the Olympic cauldron at that facility. Nice to hear from you both. Thanks for sending a question in. Where would we go and why and when? Well, it's a no-brainer for me. Fred, you know the answer to the question.
Yes, I do. Go on, then.
Mars. That would be my first stop. I would go to Mars. I am intrigued by that planet in so many ways. I would just love to stand on it and have a look around and play around a golf. I would also add that I would be really keen to visit an ice moon like Enceladus because of the growing interest in the potential for life. But if I could move beyond our solar system, I would visit our nearest neighbour, Alpha Centauri, and just see what's going on out there. That would be my choices.
That's right. Well.
And when? ASAP.
Well, there you go. Actually, you did pretty well. Your desirable visiting places tallies very well with mine. Because what I was going to say was, because Neil and Aurora said we can make it whenever we like, as well as wherever we like. And so I would like to wind the clock back, maybe 3.8 billion years, and then go to Mars, because
when it was
Mars then may have been alive. That's right. It was certainly warm and wet, with the oceans that we were just talking about earlier on. It would be extraordinary to see what Mars was like, and whether it did have vegetation, whether it had anything that is like the Earth. If it was the present time that we could take this trip, well, I would go with you to Enceladus. That was what I was going to say.
Yeah.
Stand near Enceladus' South Pole, watch the ice geysers squirting particles of ice into the atmosphere, take a shovel with us so we could start digging and find out what's in the ocean underneath the ice of Enceladus.
If you shovel.
Yeah, it's only 20 kilometers thick.
No, that's all right.
If you were feeling a bit miffed about the fact that you had to have my company with you on Enceladus,
not at all.
I might settle for Europa. And Europa being nearer, I'd get there first. And we do the same thing because there are ice geysers on Europa as well, which have been observed recently by some of the big telescopes. For outside the solar system, for me, I think your suggestion of Alpha Centauri, actually Proxima Centauri B is a Earth-like planet in orbit around one of the components of the Alpha Centauri system. So that would be where you'd want to go, probably.
Yeah.
I'd perhaps have a slightly more wishy-washy vantage point in mind, because I'd like to go somewhere sort of above the pole of, not the pole of the Earth or the pole of the Sun, but the pole of our galaxy. I'd like to squirt myself off maybe 100,000 light years upwards out of our galaxy, and then look back at it and see for real the spiral structure that we think our galaxy has, and see just what it would look like in the way that we see the Andromeda galaxy in our skies here on Earth. Wouldn't it be marvelous to see our own galaxy as an entity with its beautiful swirling spiral arms and the little pink blobs of hydrogen, which are where stars are being formed? I think that will be quite a treat.
You'd probably be disappointed to see that it's just a smiley face instead. Well, I didn't pick up on the when angle that Neil and Aurora were going on about, but if it was me, I would like to transport back to the moment when Earth was seeded with life. I'd like to witness that. That would be my moment.
I think, that's. And again,
I'd like to see how it all started, and if it was a space dog taking a dump, I'd be very disappointed.
Right, okay. From the beautiful swirling spiral arms of the galaxy to dumping space dogs. There you go.
There you go.
We cover everything on space.
Well, they asked.
They did too. And it's lovely to hear from you, Neil and Aurora. Thank you very much for the question.
Indeed, yes. And thanks to everyone contributing. We've got a whole bunch of questions in the can now, so we'll work our way through those. But please don't stop, because we love your questions. So send them in to us via our website. Very easy to do, the AMA tab, or send us your question on the right-hand side of the front page, spacenutspodcast.com or spacenuts.io. And if you are a LinkedIn user, don't forget to follow bytes.com on LinkedIn. The more people we can get there, the sooner we can start doing our live stream during the recording session to LinkedIn, as well as where we already contribute through YouTube and Facebook and I don't know what else, a couple of others. Twitter? I don't know if we do Twitter. But anyway, we want to do LinkedIn. We need 150 followers to be able to do our live stream there. And hello to our live stream watchers at the moment. Fred, that brings us to the end of the show. Thank you so much.
Great, Andrew. Always good. And we'll see you next week.
Hope so. Take care. Catch you soon. And thanks to Hugh in the studio for changing internet service providers, which he did this week. Not for any other reason than to help himself, but at least it was done. He's been talking about it for years. And from me, Andrew Dunkley, thanks for your company. Looking forward to getting together again on the very next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.